All right, so I got a question here about how to find a individual value if we're given the standard deviation. We also have some information here about the size of the coffee cup and what percent will overfill. So what we need to do here is we need to use, you can see this in the example. Um, First thing we're going to do is we're going to find the z-score that corresponds to this. But to get the z-score that corresponds to this, we're going to have to find it in the standard normal. So in this case, it overflows 1% of the time. If it overflows 1% of the time, that's this little area right here will be 1%. In this example, it's 8%, but in our example, it will be 1%. And then that means that 99% here will be to the left. So how we do that is to find the standard normal is we go to StatCrunch. StatCrunch is up in the question help. And we could also use the table, the Z table. But I'm going to use StatCrunch here. And so how we do that is we go to Stat, Calculators, and then go down to the normal calculator. There's the normal calculator there. And the standard normal, what it means for it to be the standard normal is that means that it has a mean of 0 and a standard deviation of 1. And remember, to the left, that's going to be not 50%, but 99%, because they want to know when it overflows 1% of the time. That means to the left will be 99% of the time. Let's compute that. So our z-score will be 2.33. If I round it to 2 decimal places, 2.33 will be our z-score. Our z-score will be 2.33. Okay, so there you can see I already got my z-score. And now I need to use the formula to find the individual value. So the individual value formula there will be, let's make sure we know what formula that we're using. So remember, again, if you go to the example, they give you the formula. We already got our z-score. We already did that. And then the formula that they tell us that we need to use is the individual value is equal to the mean plus the z-score times the standard deviation. In this problem, what they want is they want us to find the mean. So they want us to find this value here, represented by the Greek letter mu. So I think we got everything that we need here. We got the individual value. Let's make sure that we got the right formula here. Okay, so here's the formula. This is the individual value that we already have. This is the mean that we're looking for. I'll put like a little box around that to remind us. This is the z-score that we just found. And this is the standard deviation. They give us that information as well. So let's plug in the information that we know. The individual value in this problem, I believe it said that we have a 12-ounce cup. Yep, there it is, 12-ounce cup. Okay, so this is just following the formula. 12 equals the mean, that's what we're trying to find out. So we don't know what that is. We'll just represent that with the Greek letter mu. Plus the z-score. The z-score, we found that up here in the previous step, 2.33 times the standard deviation. I forget what the standard deviation was. I'll have to go back and look. Standard deviation of 0.04. Okay, so times 0.04. And now we got to find out what that mu value is. So let's go ahead and do that. We'll clean up our equation a little bit. We'll find out what the product of those two values are. I'll just use my calculator app and get that 2.33 Come on, calculator app. There we go. 2.33 times 0.04 times 0.04, and that gives us 0.0932. 0.0932. 0.0932. And now all we got to do is just a quick little algebra move to get mu by itself, do the opposite of addition, which is subtraction. So we'll subtract both sides by that value. And that should give us the value of the mean that we want. So we'll go 12 minus that. 12 minus 0.0932. And that'll give us the value that we want, 11.9068. Now we got to round that appropriately. So let's see what they want. That should be our answer, though. This needs to be rounded appropriately. Let's see how they want us to round. It says round to 2 decimal places. So that's going to be 11.91. 11.91. Remember, that's what we found there. 11.906. That 6 rounds that 0 up to a 1. And that should give us what we need. All right. Hope that